Great. All right. So today we're going to be talking about useful functions and one of the most important functions in pandas or in data science in general, which is the group by function. So first things first, my little brother got accepted to Carnegie Mellon, so very happy for him. Um, if you look at these lists of colleges, guys, try to get here, Berkeley. That's the best one. Okay, totally not biased. He's top 4, which is very good. Um, Yeah, we're all very happy for him. So next time you see him, congratulations. I don't know if anybody else in this call is applying for college yet, but that might be way later for you guys. Okay, so first things first. Quick recap from 2 weeks ago, which was we mentioned about extraction, right? And I noted that these square brackets were the most important extraction tools that we have, which is it's context dependent, right? So you can either take a slice of row numbers, a list of column labels, or a single column label. And yeah, that's, like I said, the most convenient and the most used extraction. Also, last time we talked about the Boolean array to extract information. If I were to put in an array of trues and falses, then I can just filter out by the indexes that are true. I'll keep the values that are true. Based on this. So this is what we went over last time. So this is how you do like the majority of filtering. So today, something very related, right, is to add and delete columns. So recall our SAT data frame. This is what we're using, and we'll be introducing a new data frame today as well when we talk about group bys and stuff. So we have a state, right, participant, critical rating, math, writing command, yada, yada. So how do you add a column? Now, you'll notice when you start coding in pandas that you have to add a column literally all the time. So they make it as convenient as possible. We can use this, the square brackets again, to reference the desired new column and just assign this column to a series of array of the appropriate length. Right, so formally what this looks like for the SAT, if I want a new column, I say SAT, I have my square brackets, then I put the new column name as a string. So this new column will go here, as you can see, and I assign it to any series as long as it has the same length as this table, right? So since columns in that table obviously have the same length, I simply add 1 to this column and I assign it to this new column. And now my new column has the math score plus 1. Right, so very simple way to add a new column. Now deleting a column is actually just as easy, right? So there's 2 general solutions. This first one is actually a lot more common, which is we can simply just extract out every column except for the ones we want to delete, right? And the reason why this is more common is because tables normally have lots of columns and we only want like 3 of them maximum, right? When we're doing our analysis. There's only 3 interesting columns. So what we can do is just simply talk about the extraction we talked about earlier. So you can put in a list of column names and just extract that out as a data frame, right? So in this case, I wanted to drop the new column I just created. I can just select every single column except for that column, right? So then I've essentially deleted it, right? Again, this is hopefully you're familiar with the syntax we've been over last time, right? You just put in a list of columns and that's what you output. Now there's an alternative way. So in the previous example, right, you might have think, okay, that was a little long, right? So if I only want to drop 1 column, there's a drop function that exists as well. So you can do dataframe.drop and then the column names, and you have to specify the axis as columns. The reason why you have to specify the axis is because the .drop method assumes you're dropping rows by default. And at least for now, we do not have to worry about dropping rows. That's like a sort of out of scope and very uncommon. Instead of dropping rows, we normally just filter them out. So yeah, if you ever want to drop a single column, just remember the columns, right? You can also pass on a list of columns to drop multiple columns if you want. That's just like a quick shortcut. Right, so an example to drop the new column I just added, right? So I have the new column name that I added before. I have access equals columns, and then I reassign to SAT, and I get my table with that column deleted. Right, so, right. So an important note is that data frames copy. So what I mean by that is that when I call SAT.drop, I do not mutate the original table. Instead, I copy the table and then mutate that table. So if you notice in this example, right, I reassign it to the variable SAT. So what I'm doing is I'm overriding the old table with my new table, this table, right? And there's many reasons for why this exists in pandas, and it's very good reasons why, because you normally never want to mess with the original data. You never want to like edit that. So just remember that if you want to reassign your table to a table with a drop column, you have to assign it, right? Exact same thing in this scenario, right? So this creates a new table. The original SAT is completely untouched, right? However, I no longer want it. I want to reassign it. I still want to keep the SAT name, right? So I've got to reassign it. If you're familiar with Python, this is just Python assignment, right? It's a very normal and very, I guess, intuitive, right? And so in this last example, notice I don't assign it to anything. This will not edit the SAT table, right? So if I just run this and I just move on, my changes will not be saved because I haven't saved this table to any variable name, right? So if you want to drop the column and you want to work with the table that you drop the column with, just make sure you remember to assign it to a variable. Right, so quick sanity check. Right, so let's say that since the SAT essay score has like not been as important since like actually the entire SAT has not been important since like the last 2 years, but like SAT essay score has not been important since I don't know when, but this is just a random date, 1858. Let's say I want to remove the writing column and subtract it from the total score, right? So the goal is to remove this column, then remake this combined column to subtract the writing score. Actually, in the interest of time, I'm just gonna tell you guys how to do it because there's like a lot of content today. I sort of like overfilled this lecture. So I guess we'll see how far we go actually. So the answer for the previous side, right? So you create a new column. In this case, I've already have a column name combined. So what this will do is it will overwrite my previous column name combined. Right, so in this case, I overwrite my column name combined with this new series, which is the combined minus the writing score. Right, then I simply drop the writing column. Right, and the end result is this new table where now my SAT score is out of the traditional 1600 that you guys are more familiar with, I think. Right. And I hope this 1232 highest average states gives you some motivation that your score is actually pretty good, because if you get above 1232, you're above average. Congratulations. Okay. So now let's talk about some useful functions that we can use in pandas. So the very first thing that I have to mention is NumPy. Now, if you're familiar with Python, you're probably already familiar with NumPy, but in case you're not, I'll go over it really quickly. Also, in case you don't have NumPy, you have to run the pip install NumPy in the VS Code terminal in your project. Don't run this in your notebook. Make sure it's in the terminal command line. If you need help with this, come talk to me after the meeting. Right, so if you want to import it, just like pandas, where we said import pandas as PD, now we just do import NumPy as NP. Again, this is just a nickname, NP. You can choose whatever you want, but this is the standard what everybody does. So for NumPy, it's just basically math, convenient math, right? So I want the mean of this series, this combined series. I want the mean score. Okay, I can just do that. Oh, sorry, my Siri just turned on. Okay, so I can just do that, right? I want the max, np.max. I just called on this. Very convenient, right? On this command. So also note that Python mean, max, they also work. So if there's a Python function, aggregate Python function that you're thinking of, that also works, right? However, NumPy's got access to a lot more things. For example, standard deviation, right? np.standard deviation is very simple, literally 5 letters, and you've got the standard deviation calculated, right? So if you look at the SAT combined right here in the column, the max score as it's hopefully, which is correct, but it's 1816, right? And then the mean of this is presumably 1590, and the standard deviation is presumably 140. More NumPy examples. You can also np.log. I think this is the natural log because that's default. You can like go into the specifications if you want, I don't know, some other log, but logarithmic transforms will become relevant. I don't know if we're even gonna get to teaching that if it's gonna be relevant for you, but it is pretty relevant in the data science field, right? You can also take the square root of every value in the column, right? So NumPy is just very convenient math. You can think of it as just like a mathematical package, right? Another very convenient function that you can run is you run on a data frame. We call dot describe. Now, what this does is that it simply just lists out a bunch of different statistics for your columns, right? So your count, your mean, your standard deviation, your min, your 25 percentile, your 50 percentile, your 75 percentile, your max, right? This is called like the interquartile range, if you guys remember from your math class. But like the count is just the number of entries, right? If you're running it on a data frame, you should expect all of these are the exact same value, right? Because your table is hopefully a rectangle. You have the mean of every column, right? So this was the mean that we got before, the mean of the combined column, right? You'll see that everything matches up. Again, this is just a very convenient function for you to use. Well, it's under the useful functions, right? I wanted to make sure you know what this function exists. If you ever want to do like some very general statistics, like the main ones, right? I mean, with these three, you can just immediately draw your box and whisker plot. I don't know if you guys know what that is either, right? Yeah. So now to get into the next useful functions, I'm going to introduce a new data frame because the SAT table is actually very simple. It's actually a very, very simple data frame, right? So the ones we're looking in the real world are going to be a lot more complex, a lot more messy. This baby names ones is, although kind of simple, it's at least a lot more complex in the SAT table, and we can see a lot more effectiveness of functions, right? So first of all, the baby names are shaped. There's 5 columns, right? The state, sex, year, name, and count. And there's over 400,000 entries. Now, the granularity data frame. What the granularity just means is that what does one row represent, right? This is like the big vocab word that when your like friend challenges you to like you're like trying to prove your smartness, you just like pull this big word out, you know. So like the granularity of this data frame. So what a single row represents in this data frame is in a specific year, how many people were born in California with that name, right? So in 1910 in California, 295 people were born named Mary, which if Mary is like the most 1910 name I've ever heard of, right? So this like sort of makes sense, right? Mary, Helen, Dorothy. These are all like ancient names, like Margaret. Yeah, you have probably name a grandmother named Margaret. Okay, nobody in 2023 is naming their child Margaret. But um, so like this. So the granularity table is just per year and per state. Well, I only took out California because otherwise it'd be way too much data. But this is just California. Um, okay, so in California, how many people were named Mary in that year, right? So this is just the baby names. I'm just introducing a new data frame here. So there's this very nice and again very convenient function called series.valueCounts. Now, what series.valueCounts does is you call it a series, as this is what the series means. It counts the number of times each value appears in that column or in that series, right? And the output is a series object. So what this will it'll be more evident what it does in an example, right? So a very clear calculation I'm on is how many different names were created per year in California, right? So I can very simply just call value counts on the year column, right? So baby names year dot value counts. So 2000 in 2007 in this table there were 2007 unique or 7,250 times 2007 appeared in that column. So what that means is in previous slide. So in this year column, 2007 appeared 7,250 times, right? But for each of these year columns, notice that it's associated with a different name, right? So this means that since 2007 appeared 7,250 times, there were 7,250 unique names created in California in 2007, right? So very similarly, you can do this for all of these, right? So, and you'll notice the least amount of unique names is 1910, and it's like 1911, 1912. This is probably because they were just starting this like census survey, right? So they didn't have much data as before. And as populations grow, more unique names are created. People are named like Nugget or something. I don't know. These people have like very creative names these days, right? So that's what value count does. There's another very nice function called series.unique. Again, you call this on a series. Again, you can just think of series as a column in a data table, right? So what this does is it returns an array of every unique value in a series. And as mentioned previously, in the sentence, it returns an array, not a series. Very importantly, it returns an array, right? So for example, if I want every unique name ever created from 1910 in California, I can simply just run baby names, and the name dot unique. Right, so this will output me every single unique instance of a name. Right. So for example, if Mary was both in 2010 and 1910, then it will only appear once in this list. Right. And at these ends, this is like the last unique names, right? So somebody named their child Zay or Zai, right? Which is I don't know what happened, but and like I said, very unique names, right? Now, a very simple calculation I want to do is how many unique names were there, right? So I simply just take the length of this array, right? Which turns out to be 20,437, which means that so there were 20,437 unique names assigned in California. I don't know why you'd want to use that statistic, but it's a very interesting thing you can just immediately calculate with exactly one line of code, right? Now, a very common problem you will encounter in your data, if you decide to pursue data science, is every value in this column unique, right? In other words, can this singular column be used as an ID? As in, well, what that further means is that can this column uniquely identify that entry in the row? Does that column define the quote unquote granularity in the row? In the real world, most of the time, one column is not good enough for that. Unless they like artificially create an ID, which is, I mean, also very common, but most of the time it's like multiple rows that define what one row is. So like in the baby names example, right? You see that it's the year and the name that sort of define a unique row, right? As opposed to just a name or just a year. So how do we sort of, given a column, how do we detect that every column or every value in that column is unique, right? So the question I would like to ask is, how can we use dot value counts or dot unique to answer this question? Oh God, it's already 9:30. Okay, so sorry. Okay, so in the interest of time, I will answer this question myself. But because we still have Groupby to go over, and that will sort of take the majority of the lecture, I'm thinking. So in the value counts, right? And like I said, counts the number of times one value appears, which basically means that if value counts, the top value is more than one, that means I counted it more than once, right? Which means every value is not unique, right? So very simply, I can just find the max of what the value count returns. And if that is one, then every column is unique, right? A very similar thing, okay, to show that, right? So if the numpy.max, which is the max of the value in the series of from the column equals one, then all the value in the columns are unique, right? So in the baby names example, baby names.count, the count that appears the most is 53,000 times, right? So obviously baby names.count is not unique, right? However, in our SAT table, the state column, as you remember, was unique. Well, it better be unique, right? Because you had a column per state. That's what the granularity of the data was, right? So SAT.value counts, and the max of that was one, right? Which means that this column, every value is unique. What we can do with unique is a very similar thing, right? So dataframe.column.unique, if it equals the number of rows, that means every column, every value in the column was unique, right? Because if it was less, that means a value appeared more than once and it was sort of like squished into that one value, right? It was sort of removed, deleted, right? So in this case, if these two are equal, if the dot unique function call returns the exact same amount of rows in the table, that or the length of it, sorry, so there's a little typo here. I should put the length. You see here, the length of it should be equal to the shape, right? So like I said, the baby names that count are unique, trivially not unique, right? So you see it outputs false. And in this case, the SAT state, which is unique, returns true, right? So this is just like a I'm sort of trying to give you intuition as to why these functions are the way they are and why they could be potentially useful, right? Now, the last function I want to sort of touch on is the last useful function I sort of want to touch on is data frames that sort values. And luckily, this does exactly what we wanted to do, which is sort the values of the data frame or the series, right? So you can also call it a series. So when you call it a series, all that does is that it just sorts the values in the series, right? So I want my bay names on name column, and I want to sort it by name, right? If you see here, Adan is like the first one alphabetical name that existed in California, right? And notice that this does not remove duplicates. I actually have no. Okay, sorry. It says Adan with an E over here. Okay, that's why this one appeared first, right? So this very simple function call just outputs a series with the name sorted, right? Notice that the IDs, the original index, did not change, so you can still like figure out what that says. And if you, maybe it was like 2 weeks ago or last week, we can reset this index if we want. All right. Now you can also call it on the data frame, perhaps the much more interesting scenario, right? Where if you call it on a sort values and you input a column name, it'll sort the entire table by that column name, right? So if I say baby names dot sort values and then by name, this no longer returns a series. What this returns is the entire table just sorted in that exact same order as what we saw before, right? With Aiden, Adan first. Also, let's say you want to sort it with the largest number first instead, right? You simply just add a keyword in here, comma, and you put ascending equals false, which means that you want it descending. Right? You would want Zyrus would appear first, and Zyro would appear here, right? So imagine you wanted like this is like intuitively already very useful, right? Sorting is like obviously a big thing in computer science, right? And if you wanted like, for example, the most common, I don't know, the highest SAT score by state, if that data frame was not already sorted, right? You can just call sort values and just pick out the values that you want. Now, this next section is group by, which will, I think, take the majority of the lecture. But before that, let's do like a quick demo of what we've done so far. So again, this is the SAT data frame. So this is how you create a new column, right? So this syntax right here, I assign it to a series of the same lengths, very importantly. And you see my new column, right? If I can also just select every single, sorry. Let's say I want to delete this new column I just created. I can just select every column that is not that column. Note that I did not assign the value of SAT to this statement, right? Which means that, let's see here, if I still have SAT, I still have my new column, right? Because I did not assign this value. I basically just created this table in the void and just outputted it, right? So SAT, this is what I meant by data frames copy, right? So my SAT can put a new column right here. Another way to delete it is by dropping the column. And you see this time I've assigned it, right? So syntax is just dot drop, you put the new column, the name of the new column, or the name of the column you want to delete, and then the axis, and very nicely, the column is deleted. This was like the problem I was talking about, if I want to remove the writing score and subtract it from the combined, right, which I explained earlier. Very simply, let's do this. Simply overwrite the SAT.combined column, then drop the writing column, right? And notice this actually shifts this ranking a little bit. If I can find it over here, for example, right? 1176 is greater than 1174, so the SAT score artificially increased Kentucky, I guess. That's what you can take away from that. We also talked about NumPy, right? So I want the mean of the combined column. I can just okay, so this is the new value because I've subtracted from the combined. This is no longer like 1590 or whatever, right? I can get the standard deviation as well. I can take the log of the column for some well, I don't know if we'll get to this like I said before, but logarithmic transformations are very important. Also take the square root if we want. The very useful function I talked about earlier, the describe function, which just returns us all the summary statistics that we would ever want in a very nice and compact table per column. right? We can call value counts on like participation rate, but participation rate is like pretty like unique, I guess. So it's like not very interesting, which is why I introduced the baby names table, right? So this just means 3 states have 100% participation rate. 3 states have a 4.6% participation rate. 2 states have a 63.1% participation rate. This is what it means, right? It's just the number of times that value appears in the column. Oh, also, I forgot to mention this earlier, but value counts automatically sorts by the number of like the most amount of times it appears. So 100 being like the most common participation rate, I guess it's sorted by this value here. Now introducing the baby names data frame. This is like this. Don't even just completely ignore this .txt, .gz stuff. Okay, completely ignore this. Just abstraction. I have the table out, right? I took the first 10 entries, which is why it looks so small. But this is what we're looking at the slideshow. I call baby names like shape. Turns out I have over 400,000 rows. I want I can call value counts on year, right? I did this in the slides as well. And this just outputs the number of times 2007 appears in the year column, right, which is 7,000 times. Right, so 2012 appears around 7,000 times as well. The dot unique function was another function, right, that we talked about, where it's just an outputs an array. Notice that this is completely different from a series. Mainly because if we like sort of squash two values together, we don't know which index to keep. So Pandas just says, okay, I actually don't want any of the indexes at all. So it just outputs an array. So if I take the length of unique, which basically just means how many unique names are ever created, right? It's over 20,000, right? So the question I proposed in the slides, which was like the max of the, how do I check if every single value in that column is unique, which means you can use as in like an identifier column, right? So obviously the max of baby names that count is not 1, so therefore it's not unique, right? But the state column is unique, right? The other way to do it is check if the dot unique returns the exact same amount of rows, which again, this is not unique, so it's false. But this one is true. We can sort values of the series or return a series, the sorted values. We can also sort values called on the data frame instead, and return a table with the table sorted by the column. All right, so those are like probably like the most simple, most basic, useful functions that there are. I think value counts is probably one of the more important ones that you should probably remember. Obviously, you have to become very proficient at adding and deleting columns, because this will become very integral in everything, I guess. So now let's talk about the big topic, group by. And you've heard me talk about group by all the time in like the past few weeks, because it is so fundamental and it is so widely used in the data science world that you have to like sort of fully understand it to become very proficient, I guess, data scientist, right? So first of all, I wanted to give you guys some intuition on why do we even need this? So why is this important, right? This Jesse guy's been talking about it all the time. Why is he so obsessed with the group by idea, right? So at a high level, what group by does is that it groups together rows that falls under the same categories then performs, that's bad grammar, sorry, then performs an operation that aggregates across all rows in the category. If you're unfamiliar with aggregate means, it just means given like a list of values, one value, I squash all the values into one value that represents the entire data or that like subgroup of data, right? So, and this is a function, by the way. So an example would be like the sum. So I have like 5 numbers. I want to squash them into one. One way to do that is to sum them. Another way is the mean, right? There's obviously an endless amount of aggregate functions, which I will go into depth about later. But like I said, at a high level, what I'm doing is I'm grouping together rows in the data frame that fall under the same category. Then I'm performing an aggregate function on those categories, right? So for example, in baby names, we can group together all rows from the same year, then sum up the total babies, right? Or sum of like the count, which will be the number of babies born that year, right? So again, so as to like why is it important, right? So grouping is a very, very powerful tool to perform large operations all at once, and it's very effective at summarizing trends in a data set. And this second point, I will give a little sneak peek on what I mean by this. But next week, when I talk about data visualization, I'm hoping this will become a lot more apparent. Okay. So this was a visualization. This is like definitely what I would fall back on if you're ever confused on what Groupby does. But this is a very nice looking, I guess, table, right? So as mentioned before, I have my original data frame here. Then I call group, right? Now, this is the group by part, right? So I know you can think of it as 2 steps. I group by, then I aggregate, right? So the group by part, I group by this ABC column. So if you see this output here, I have all the rows with A in it, all the rows with B in it, and then all the rows in C in it, right? After the group by, you can think of it as a collection of mini tables, right? They're called like group by objects, but you don't really need to care what that is. But you can think of it as like mini tables, where in every table, they share this value you just group by it on, right? And normally, okay, this is normally a column, right? So you call group by on a column. So this is the output of the group by. Just remember this, okay? So it's these mini tables that you have to remember, right? Then on these mini tables, you call an aggregate function on these values, right? And then it gets outputted in the final table as this one value. So in this graph, right, the aggregate function is min. So out of these 3 values in A, this column, these 3 values, I aggregate by the min, which means that I have the values 3, 1, and 2. What is the min of 3, 1, and 2? Oh, well, that's just 1. So I output 1 right here. Now this next set of rows in this only this A category. Remember, only this A category, right? What is the min of these 3 numbers? 12, 2, and 8. Well, it's 2, right? So I output 2 right here. I'll trace out this second one as well, because this is like the fundamental slide to understanding what group by does, right? So B here, I group by B, I collect all these B columns, then I have them here, then I aggregate by column. So these 1 and 5, what's the min of 1 and 5? Well, that's just 1, the minimum value, right? So I output 1 right here. What's the minimum of 7 and 7? then I output 7. Right. So this is like sort of exactly what's going on. One key thing to realize is that the leftmost column of our new data frame are the unique column values, right? The unique categories that I group by. And each of these categories will have only one, exactly one value for that column, right? And so that's what the collect function is, what the aggregate function does. So now a formal definition of what data frame.groupby does. So an entire .groupby operation, okay, so this is the groupby and the aggregate, splits the data frame into categories, applying a function to those categories, and combines the rows back into a data, right? So if you see in the previous slide, I split it up into categories, then I mesh these categories together into this new data frame from this table to this table, right? So that's like the whole process. So calling .groupby only. So I've only called .groupby so far. This generates what's called a data frame groupby object, which you don't really need to care what that means, but all you need to care about is that these are mini sub data frames. They're mini tables, okay? And each subframe or mini table contains all rows that correspond to the same group, the same category that you just grouped by, right? So if I just call baby names on group by year, what will happen is that in our baby name table, right, I group by year. So all these instances of 1910, you see 1910, 1910, they get grouped by together over here. Right? All these instances of 2005 will be put together in this a little mini data frame. Right? All these instances of 2015 will be put together in this mini data frame. Right? These data frames are completely separate from each other. And you can think of them as just completely new tables. So here I've got 3 new complete tables. You can think of it like that, right? Note that this is actually not is what's happening under the hood. If you try to output this value, you get like this object. It's actually like not what's actually happening, but you should think that this is what's happening because that's what's like abstractly that's what's happening, if that makes any sense. So you should think like this, right? You think that you're creating categories when you group by, right? And now the second step is to aggregate by this value. I have 10 minutes left. Okay, sounds good. So data frame.groupby.aggregate, right? As mentioned in the previous slide, these data frame.groupby objects, you cannot work with them at all. They're useless. These like mini data, it's quote unquote mini data frames. I don't know why they made it like that. It's just the way it is, right? But what the group by actually outputs is, like I said, very useless, right? So instead, we transform an object back into a data frame using this .agg, this .aggregate, right? So as mentioned before, the goal is to aggregate the values into one value, right? So right here, I group by these my mini tables, then I aggregate by the sum. In this graph, I've omitted all the non-numerical values. I'll talk about that a little later. This is just like you'll see what I mean by that. But so if I .aggregate, I input the sum function. I pretty much I smush every single row in that mini data frame into one row, right? With all the rows and the columns squished together into one row, and that row, how do I squish them? Is with the sum, right? So if I look at this count, I have, well, in this case, I only have 2 rows, right? In this sub data frame. How do I squish them together? I sum them together, right? So for now, just ignore these word columns because summing names doesn't really make sense. It'll return like a string, but like you don't have to worry about that, right? So what's 295 plus 47? That's 342, right? What's 20 plus 37? That's 57, right? So again, you think of it as I'm squishing all the values into one row. And how do I squish that value? It's with this aggregate function, right? So this entire operation, what just happened was that I took my original data frame, I grouped by the year, then all the years as a separate data frame, I squished that into one row. And how I squished that into one row was with this sum. Right, so this is the entire operation. So our end goal is right here. Right, this is our end result. So putting it all together, right? So it'd be a data frame dot group by. I call it on a column, then I aggregate by some function. So for example, in the baby names example, the function that I like sort of illustrated here was we can group together all the rows from the year, then sum up the total number of babies born that year, right? So in this case, to get rid of the non-numeric columns that I talked about, I simply just only selected the year and count column, right? This is like I said, pandas makes it very convenient for us, right? So you can just think as these like Mary, this name column and this gender column and the CA column just don't exist, right? In this example, right? So I call this dot group by year. I get to here, then how do I want to squash the rows? I want the sum. So that aggregate sum, right? And I output this table. There's more convenient ways to get rid of the irrelevant columns, as I mentioned before. Perhaps the most common, way more common way is to simply select the columns in the output right after the group by. So this is Pandas allows you to like sort of do this selection before you aggregate, which is very convenient, right? So instead of like selecting year and count, I simply just only took out the count column. Keep in mind that I didn't have to select the year column because that's what I'm grouping by, right? So that's inevitably going to be in that column, right? Or in the new table. And I go dot aggregate on sum. Also note, I can just change the sum because sum is so commonly used. I can just do sum like this. And then another, if I'm like feeling, I don't know, super fancy, right? I can group by sum and then put numeric only equals true in here. I don't know why you want to do that, but yeah. All three of these things, I'll put the exact same piece of code. It's literally your preference what you want to write. I definitely prefer the second one here. This is probably what I would write most often. Also, notice these double brackets. If you remember from our extraction lecture, which was 2 weeks ago, right? If I put double brackets, that means I'm extracting out a table, right? And not a series. So if I only want the series, then I simply just put one bracket. Also note that our new index is exactly what we group by, right? So I remember I did talk about this before, but if you want to reset the index, you can do that as well, right? So just keep in mind that our new index is what we just group by. So I'll talk I only have like 4 minutes left, so I'll make it hopefully quick. But with the aggregate functions, let's talk about what we can aggregate by, right? Like what are our common choices, right? So just to redefine it, the aggregate function aggregates several values into one summary value, right? Think of it as squishing all the rows into one row. But what this means is that you can create whatever function you want that squishes the rows, right? So if you're familiar with Python or like very proficient in Python, you can use like a lambda function. You can self-create your own function just squish it, right? So this gives you like endless possibilities on how you want to aggregate your values, right? You can use NumPy functions, right? You can use you can aggregate by np.max, np.min. Also Python functions work as well, sum, max, etc. Right? Right. So the ones we'll be primarily using, we'll just use the ones from pandas, right? So you can aggregate by sum, max, min, mean, first, and last. These are like definitely the most useful ones out of all. You can also aggregate by like median, but that's like a lot rarer. Keep in mind that first, all it does is just return the first value in the mini data frame. So like back in this example, but if this aggregate is first, I'll just get this value right here. I will get this value right here. I get this value right here. Oh, okay. And then just to like give you a little insight, right, and why group by is so powerful. So if you think about this group by year and then the count, and we aggregate by sum, what did we actually just calculate? Right? What are we in this baby names table? Okay, maybe it's a little too far back, but whatever. So in this group by, what did we actually just calculate, right? What are these final values, right? If you think about it, what we've done is we've summed all the counts of the names every year. So what that returns is the number of people born in that year, right? In California. Now, that's a very interesting statistic, right? That we can just get from literally one line of code. And notice I can get it for literally every year, right? And then I can do further things, right? Like sort it, what I talked about before, to figure out which year did we have the greatest population increase, by like birth rate wise, right? And a little sneak peek in the next week, right? Oh, okay. Okay. Actually, I have no idea how accurate this data is, but just treat it like it's accurate. At least it feels accurate, right? So I can do simply plot it, and we can see the population, the number of people born every year, slowly increase as days go by, and then we hit a peak somewhere in like 1990 in California. We hit a peak in 1990, and then the number of babies born every year has been slowly declining. Right. Keep in mind, we discovered this with literally one group by function call. Right. So I'm hoping this gives you guys a little insight on how powerful this group by is, and how essential this is. Also, a quick note: you can group by multiple columns. But I won't go into the specific details of that in this lecture. This will be probably later when I talk about like pivot tables. But next week, it's already 10, sorry. But next week I'll be cutting a lot of like pandas and going straight into graphing because I think that's more interesting. So this graph I just made, this will be like literally the first thing we learn next time. I'll talk about date time objects, which is very useful when you're graphing. So like instead of this year, I'll make a date time object that I can graph instead. And then way later, we can talk about merging tables. If I have two tables, how do I merge them together? Pivot tables, which this is like group by two objects, which I talked about a little bit. And we will also talk about potentially if we want strings, like if I, for example, want all the baby names that starts with A, for example, then there's ways to do that. There's like an in extract, and then I'll also talk about if we really want. This is like way later. It's like custom sorts. I want to sort my data frame in a unique way. How do I do that? Right. And so yeah, that's all for this week. And yeah, and remember this graphic right here. What we're doing. Okay, what we're doing on a group by. This just look at this picture, study this picture, understand this picture, and you'll be very set. Right? Yeah, look at this right here. It's very important. This group by. All right, thank you. And Shajin, you can